Hello everyone, in this lecture we are going to look at how we can create the design load combination. A very important instruction before going into the design part. We have to create the design load combination according to our code before going into the design part. Now I am going to open my whiteboard to explain you the design load combination. I am going to write a topic name called design load combination. Design load combination. In this particular topic, we are going to look at what all the different load combinations are available in the IS code for designing the structural elements like beam, column, slab, shear wall, footings. I will consider two types of the design load combination. The first I will consider, which will be without earthquake effect, and the second will be with earthquake effect. Earthquake effect. Now the word only says you that in this particular load combination you are not going to consider any earthquake load cases. In this type of the load combination you are going to consider earthquake effect also while considering the load combination. It means that you are going to take the earthquake load also while considering the load combination. Now I will write a load combination which will not consider any earthquake load cases in the load combination. So these are the load combinations I am going to write. The first load combination for the strength design, which will not consider the earthquake effect, will be 1.5 dead load, and second will be 1.5 dead load plus 1.5 live load. You can look at that we have not considered any earthquake load cases while defining the load combinations. So these are the two load combinations you can use it when you are not considering any earthquake load cases in your design. Now come to the topic where you have to consider the earthquake effect in the load combinations. One very important thing I would like to mention that when you are considering the design load combination with earthquake effect, there is a two type of the earthquake effect can be possible in the design load combination. The first will be when you are considering only the static load cases. So when you are considering the static load cases of earthquake, then there will be different load combination, and when you are considering a dynamic load cases, dynamic load case of earthquake, then this will have a different load combination. Now one by one we are going to look at that what the load combinations shall be used when you are considering only the earthquake load cases which will consider the static, and what are the load combination you are going to use when you are considering the dynamic load cases for the earthquake design of the building. So these are the very important two things that we have to consider it while designing the structures with earthquake effect load combination. Now we are going to see one by one. Now I will write a load combination which will be used for designing the structural element when you are considering only the earthquake static load cases for the design. So the first load combination you can write here, that will be 1.2 dead load plus 1.2 live load and plus 1.2 EQ. If you are considering in the x direction, then you can consider EQX. Then the second load combination will be 1.2 dead load plus 1.2 live load, then this will be a minus here, and then again 1.2 EQ x will come here. The one time will be plus and another time will be of minus. So you know that a static earthquake load case is the static, so that there will be a plus and minus also while considering the load combination. So if you are considering for the x, then there will be a plus x, then another will be of minus x. Same if you are considering for the y, then plus y and then minus y will be coming here. Now consider the third load combination, which will be of 1.2 dead load plus 1.2 live load, then I will consider plus 1.2 EQY, and other will be load combination will be 1.2 dead load plus 1.2 live load, then it will be minus 1.2 EQY. So one I have considered plus, then another way I have considered minus. And if you look at it, once I have considered x, this all 2, then another I have considered y, this all 2. Now come to the fifth load combination, which will be of 1.5 dead load plus 1.5 EQX. So once it will be considered plus, then another will be of minus 1. So the sixth load combination will be of 1.5 dead load minus 1.5 EQX. Now if you consider the x, then another will be of y also. So seventh load combination will become 1.5 dead load plus 1.5 EQY. So eighth load combination will consider of minus 1. So 8 will be of 1.5 dead load minus 1.5 EQY. Now come to the ninth load combination, which will be of 0.9 dead load plus 1.5 EQX. So once you consider plus, then another will be of minus 1. So the 10th load combination, which will be of 0.9 dead load minus 1.5 EQX. So if you consider the x1, then another will be of y1 also. So the 11th will be of 0.9 dead load plus 1.5 EQY, then 12th will be of minus 1. So this will be of 0.9 dead load minus 1.5 EQY. This load combination can be rewrite into the sort also. So this load combination you can write like that: 1.2 dead load plus live load plus minus EQX or EQY. So this is the same thing I have written into the fourth load combination here. So plus minus, then once it will be considered of EQX, then another will be considered of EQY. So these load combinations can be rewrite like that also. But when you considering the software, then you have to consider everyone as a separate only. But someone, if you ask that what are the earthquake load combinations for the static one, then you can write like that also. There will be not any problem. So this also can be rewrite as 1.5 dead load plus minus EQX or EQY. So these load combinations also can be rewrite in the sort like 0.9 dead load, and you can write plus minus, you have to give it 1.5 here, and you can keep it EQX and EQY in the bracket or EQY. So these load combinations in the sort you can write like this. This load combinations in the sort you can write this. This load combination in the sort you can write it. But when you have to define in the software, you have to define all the 12th load combinations separately in the ETABS software. So all the 12th load combination will be defined separately in the ETABS software. That you have to keep it in your mind. Now let us consider the dynamic load combination for the earthquake design. So I'm going to write this dynamic load combination here. So the first load combination which will be considered in the dynamic load cases will be of 1.2 dead load plus 1.2 live load plus 1.2 spec X. The second load combination will be of 1.2 dead load plus 1.2 live load plus 1.2 spec Y. One very important thing that you have to notice here, that when we were considering for the static one load combination, we are considering the plus minus also. But in the dynamic load cases, or in the dynamic load combination, we don't consider the minus and all. So there will be only the plus one. The reason why in the load combination of the static load case contains plus minus, because the static load case is your the vector quantity and your dynamic is your scalar quantity. So as you know that a vector quantity will contains direction also, and a scalar quantity do not contain direction, it has only the magnitude, but plus minus actually indicates you the direction. Now come to the third load combination of the dynamic load cases, which will be of 1.5 dead load plus 1.5 spec x. The fourth load combination will be of 1.5 dead load plus 1.5 spec x. Sorry, spec y, it will be there another. Now the fifth load combination will be of 0.9 dead load, and other will be of 1 plus 1.5 spec x, and the sixth load combination will be of 0.9 dead load plus 1.5 spec y. So you can look at the difference between the static load combination and dynamic load combination is that in the static one we have considered the minus 1 also, but in the dynamic one we have not considered the minus 1. So here the total load combinations are 6 only, and in the static one the total load combination is of 12. Now these load combinations also can be written in the short also. So this combination I can write in the short like 1.2 dead load plus spec x or spec y. So this can be written in the short. So this also can be written in the short like 1.5 dead load plus spec x or spec y. This also can be written in the short, which will be of 0.9 dead load, and other will be plus 1.5 spec x or spec y. So these load combinations can be written in the short. So in the software of ETABS you have to define all the 6 load combination for defining the dynamic load combination. So the total load combination, if you count static plus dynamic, then it will be of 18 load combination. 12 will be of static one and 6 will be of dynamic one. So 6 plus 12, it will be of 18 load combination. A very important note, you have to consider it while designing the structural element in your ETABS software or any other software it may be. What is the important note you have to keep it is that when you're considering your dynamic load cases, and also if you're considering the static load cases, in that case you have to take the load combination only from the dynamic one or only from the static one only. You have to not take the load combination both of it together. That you have to keep it in your mind while designing the structural element. Now I will write a very important note, which is do not take static and dynamic load combination together. So if you're considering the dynamic one, then take only the dynamic load combination. If you're considering the static one, then you consider only the static load combination. You have to delete these all the 6 load combination when you're considering only the static one, and if you're considering the dynamic one, then you have to delete all the 12th load combination while considering the dynamic load combination. So this is the very important note. We have to keep it in the mind while designing the structural element in your software. Now come back to the ETABS software for creating these all the load combination in the software. So I am in the ETABS software, and here we are going to create the load combinations. So you have to go into define option. Here you will find a load combination option. You will click on the load combination and this window will come here. There is a two way of adding the load combination in the ETABS software. The first way is that you can add the load combination manually. So you can just click on add a new combo and from here you can add the combination manually. The other way is that you can automatically generate the load combination in the ETABS software. So you only need to click on add default design combo. So on the basis of the load cases, it will generate you the load combination. So let us add this. So you can just click on add default design combo and here you have to select the concrete frame design. You have to click this and you have to make it this as a convertible. So you also click this also and after that you have to give it OK. Now you can look at that software has automatically generated you the load combination. Now you can see that total load combination generated by the software is of 20. So we have seen that when you're considering the dynamic plus static, there were 18 load combination. So if you're considering without earthquake effect, then there will be two more load combinations will be added. So if you just see that these two load combination 1.5 dead load plus 1.5 dead load plus live load also will be added. So total there will be of 20 load combination. So two of it will be of without earthquake effect, then 18 will be of with earthquake effect, and that also the static one will be of 12 one and the 6 will be of the dynamic one. So same thing it has been generated by the software also. So total load combinations generated by the software is of 20 load combination. In note I told you that you no need to consider the static load combination and the dynamic load combination together. So that's the reason while we are going to delete the static load combination from our design. If you're designing the structure through the static one, then you have to remove the dynamic one, and if you design the structure through the dynamic load combination, then you have to delete the static one. So here I am going to delete the static load combinations from here. So what I will do here, I already told you that the first and the second will be of without the earthquake effect, so we are not going to delete these two, and after that we are going to delete the static one. So the static one will be start from S3 and it will be end at S14. So from here it will be end. So from S3 to S14 there will be static load combinations, and this I have to delete it because I already wrote in the note that you no need to consider the both of the load combination together. So that's the reason why we are deleting this all the load combination from our ETABS software, which is automatically generated by software. If you're adding the load combination manually, then you no need to delete because you are not going to add it the load combination of the static one, you are going to add it only for the dynamic one. So when you're considering automatically design load combination generation, in that case only you have to delete this. So I will go with the delete option and I will delete this. Now you can see that we are left with the few load combination which will be of UDCON 1, UDCON 2, and there will be of UDCON S15, 16, 17, 18, 19, 20. So if you count from 15, 1, 2, 3, 4, 5, 6. So there will be of 6 load combinations. So you can just see that the 6 load combination of the dynamic will be of this, plus there will be of 2 more load combination which will be of without the earthquake load. So if you just see here that this load combination I am talking about, so the first 2 will be of this one and rest of the 6 will be of dynamic load combinations. Now come to the ETABS software again. Now you can rename this load combination with the proper name. So you can select the load combination and you can go to the modify option here and you can rename this. So this load combination will be of 1.5 dead load. Now you give it OK. This will be of 1.5 dead load plus 1.5 live load. Now you give it OK. Now you can also rename your dynamic load combinations also. So I will start with UDCON S15. So I will select and I will modify this and I will rename this. So you can see that we have a load combination which is consist of 1.2. So I will just write 1.2 here and I will give the bracket sign and I will write dead load plus live load plus a spec. So this is the load combinations consist of a spec x, so I will give it a spec x and I will close this bracket. Now I will give it OK. Now again I will select UDCON S16, again I will modify this. So in this you can see that this is the load combination which consists of a spec y. So I will just rename this with 1.2. I will give the bracket sign, then dead load plus live load, then I will consider a spec y also, and I will close the bracket, then I will give it OK sign. Then again I will select the UD cone S17, and again I will just modify this. Again I will write with the load combination of 1.5. This is the 1.5 load combination, so you just give 1.5, give the bracket sign, again you add dead load plus a spec x, you close the bracket, you give it OK sign. Again you select the UD cone S18, you modify this. So this consists of a spec y with 1.5 as a load factor, so 1.5 factor, give the bracket sign, give the dead load, again you give it plus sign, then a spec y will come, you close the bracket. You can see that spec y is there. Now you give it OK sign. Again select the UD cone S19, you modify this, you rename this with 0.9 dead load, then you give it a plus sign with factor of 1.5, and again this will become with a spec x, because this is a spec x with 1.5, you give it OK sign. And the last is your UD cone S20, you select the UD cone S20, you modify this, and you can rename this with 0.9 dead load plus there will be a 1.5 a spec y, you give it OK sign, and finally you give it OK.